relatively easy to have production-ready GPU-specific use cases on-premise. You have just-in-time infrastructure through Cluster API. You maximize GPU utilization through HAMi. You simplify deploying LLM models on Kaito, and you do smart routing through LLMD. And about the rest of the production readiness, that comes from Kubernetes. You already do it. Okay, so you have resilience, high availability. You have observability solutions. They just need additional plugins such as DCGM exporter for GPUs, or specifically tailored dashboards, or maybe VLLM exporters to see how the model is behaving, or this kind of things. But the rest stays the same. You can keep the same platform engineering team as before, and they will handle AI inference as another workload. And finally, I will just show how this actually can be still cost-effective by doing a small comparison of price. I took here as a baseline a consumer-grade GPU, which is an RTX 3090 to run a small model, a 7B model. And my calculations give me about 44% less cost per token compared to OpenRouter, which is very cheap router for different APIs. And if you compare that just to kind of the cloud, the AWS, you have even more. You have 85% economy. And thanks to projects like HAMi, you have up to 3 times as much GPU utilization as without, or in other words, you have 70% lower infrastructure cost for the same level of service at the end. So, takeaways from this talk. The need for local AI inference is growing. However, Kubernetes is ready for it. And there are these projects, HAMi, Kaito, LLMD, Cluster API, that can cater to it. So please, go ahead and give them some love. I put the QR codes here so that you can take a look at them, test them, create maybe tickets, documentation, etc., etc. This will be very welcome. So I will leave the screen for a little while. I think I went a little bit over. No, actually I didn't. Okay, so I have a little bit time. We have a little bit more time. Please go ahead with your questions if you have any. Microphone, please.
Thank you.
Yeah.
Thank you for the talk, really interesting. I have a question regarding the smaller models.
Yeah.
So you had a lot of use cases. So I feel a little bit like they are a little bit left behind because everybody's looking at the GLMs and MIMOs and MinMax. So what is currently kind of a normal use case which companies would use? Because I think there is not much talk about what actually can be done so that this can enable all of these platforms even more.
So if I understand your question right, are you asking about the use case or a particular model?
The general use case viability for the small models. For example, the 7B model.
Yeah. No, sorry, no, this is not the right slide.
The calculations.
Yeah.
So, I mean, the 7B model is it is capable. The question is always like
The question is
the specs and the benchmarks and how real this actually is for a company.
absolutely. So the question is, what is the use case? If you want a general model that has like a very high level of intelligence, then yeah, the 7B will not be enough. However, all these use cases that you see here, a 7B can do them very well, very well. I'm thinking about summarization, for example. Summarization is something that is like even smaller models can do that. Even 3B models can do that very well, especially if it's like a single language. You can also, with a 7B, you can even do like translation. You can do extraction, all of that. All these use cases, maybe just the code, you might need something that is a bit more intelligent, but OCR, there are, very recently I read about an OCR model, 3B, that has more than 95% of accuracy on like huge amounts of documents, okay? So classification, it's, you know, natural language. As long as you don't go into the territory of real intelligence and like planning and architecture, up to 7B models are very capable of doing all of these. Okay, so for example, you give them a document in like as RAG, you store that into vector database, and you run the model on top of that. Works quite well. You can extract the data. Extraction, same. It will format something that is quite unstructured into, for example, a structured JSON file that you can afterwards, you know, put into your databases. All of these use cases, which are real. I mean, any company needs to chat with their document, right? Any company needs to extract data that is messy. Multiple enterprises need OCR because they have documents that are not digitized. Classification is a very boring use case. You know, you create a ticket and there's an LLM that just routes the need. And even like your AI agent does that already. Like when you talk to, when you send a request to Claude Code, it doesn't immediately use the most intelligent model. It analyzes the request through sometimes the lower model, Haiku model, and then it routes that into the right one. So all of these are actual use cases for very small models.
Thank you for the talk.
Thank you.
I wanted to ask, I think you've talked like about cluster API to do like this on-demand thing.
Yeah.
I always think about, I mean, I have a little GPU for my home lab server
Yeah.
where I want to do like small models and evaluate them.
Yeah.
But the idle cost of the wattage of the graphics card is at some point not really worth it because I pay more for the idle cost there than I do without it, and then I could also just go to Open Router and use the smaller models. So like, what is your point on that?
So the use case for home lab is a little bit complex because we don't have some enterprise level kind of automation. In, you know, enterprise servers, they don't need to be data center grade, but they still have things like BMC, you know, onboard management stuff. That means that a server can be off for a while until it is needed, and that's where something like Cluster API for Metal Cube can connect to the BMC through the Redfish protocol, spin up the server completely, and you will have a new GPU node in your cluster. Okay. In the home lab use case on a single GPU, you rarely have this kind of thing, right? But I do absolutely understand that because I have the same kind of use case. Yeah, maybe, however, what can be done is if you do GPU partitioning, you can just decrease the power usage. But idle power usage, we cannot do much about it because we cannot just shut down and then power on again the server at home. Yeah, you're welcome. Any other question? Yeah, there is one behind.
GPU provided.
Yeah.
And I've had, like, mainly working with NVIDIA GPUs, I've had many headaches with them not being very friendly to you when you try to do like extra virtualization. Even doing basic GPU pass-through didn't work a few years ago. They locked it down like in kernel level of the GPU. So my question is like, how have you worked with HAMi, and do you have like something to add about how like open source could interact with this all sorts of NVIDIA, and how much overhead is added when not using like NVIDIA provided enterprise features, which goes like around the line?
Absolutely. So HAMi has multiple approaches for partitioning. There is one approach that is nearly possible every time, but not extremely useful, and that is time partitioning. That means that it exists for CPUs as well. You just say the GPU will be used 25% of the time for this task, and 25% of the task for that task, and 50% for that other task. So that exists and doesn't need anything, I would say, on the hardware level. Nearly any kind of GPU can be supported. But specifically for NVIDIA, they also support some more low-level kind of partitioning through low-level libraries. I don't know exactly how they do it. What I know is that they actually achieve the same as vGPU from NVIDIA in terms of performance, but by partitioning at the driver level, at the kernel level, okay? And they can tell you your, I don't know, 7,000 CUDA core GPU would have 1,000 for this task, will have 2,000 for that other, etc., okay? And same for the VRAM. So yeah, but surprisingly enough, an open source project is capable of doing that, at least for NVIDIA, because it's very close to how the NVIDIA driver works with the kernel. So they, in my research, they are not yet able to do it for Intel, for example. So yeah, that's the kind of thing that. Other questions? Cool. So let me just put the last slide, because if you'd like, please go and give some feedback to this session. And if you're interested, you will find here my LinkedIn profile in that QR code. Please don't hesitate to connect. And let me know if you have any questions. I will be hanging around afterwards. Thank you very much.